Welcome back, math lovers. So, meeting you in miscellaneous part 2 of permutations combinations. Question number 1. We're talking about a set X which is having first 7 natural numbers. They're asking us the number of subsets, number of proper subsets of X containing 7. So, let me first tell you what is a subset. So, from a particular set, when you pick some elements and make a new set, it's called as a subset. So if you pick all the elements of a set and make a new set, then such a subset alone will be not called as a proper subset. You should not be taking all the elements. Okay. So now with that idea, so now they are saying they're looking for the proper subsets which contain 7 in it. Meaning your subsets that you're going to make can have 7 in it, followed by other elements. Maybe just 7 alone, or 7 followed by just one other element, or 7 followed by two other elements, or 7 followed by three other elements, like that, so on. Okay. So which means apart from 7, there are remaining 6 other elements. But if you pick all the 6 other elements, then it won't be called as a proper subset. So you are allowed to pick maximum of only 5 elements then. So it can be out of 6, you can pick 5, or you can pick 4 elements, or you can pick 3 elements, or you can pick 2 elements, or you can pick 1 element, or you decide not to pick anything. But this is very similar to that previous question about light illumination in a room. So here, if the only one term is being absent, that is 6e6 is absent, because if I pull out all the 6 other elements, including 7, it will not become a proper subset. But just for calculative purposes, we know when we add all the binomial coefficients of any particular row, it will be equal to 2 power n. So what I'm going to do here is, I'm going to add and subtract 6e6. I'm going to add and subtract 6e6. So the value of this will become equal to 2 power 6, and 66 is nothing but 1. So 64 minus 1, 63 becomes the total number of proper subsets. Hope you like this miscellaneous question. So moving forward, question number 2, they're asking us a student is allowed to select at most n books from a collection of 2n plus 1 books if total number of ways in which a student selects at least one book is 63, find n is our question. So they are given two conditions, utmost conditions as well as at least condition. He has to choose at least one book and he has to choose at most n books. So 2n plus 1 books is the total number of books. That seems to be an odd number here. So from 2n plus 1 books, he is allowed to pick one book, or he is allowed to pick two books, he is allowed to pick three books, so on till he is allowed to pick maximum of n books. Okay, so these are all our success cases. Okay, so but 2n plus 1 C0 is not allowed because he has to pick at least one book. But yet again, this is very similar to our any binomial row. For example, I take any odd number, 3. So 3C0, 3C1, 3C2, 3C3. The values of them are 1, 3, 3, 1. So you can understand here. So this position, okay, this position comes like plus 1. When I do 3 plus 1, it becomes 4. 4 by 2 is 2. Okay. So we are just looking at what is exactly at the midway. What is exactly at the midway. And this position, if you see, It's like 3 plus 1, 4. 4 by 2 minus 1. So if I add the first half of the elements, I would be getting the total sum as half of the total sum. Here you can see 1 plus 3 plus 3 plus 1 is actually adding up to 8. But 1 plus 3 alone will be adding up to 4, which is half of 8. Okay. So I understand like for 2n plus 1, for 2n plus 1, if you do plus 1, for odd rows, that's a rule. If you do plus 1 and divided by 2, so see what you get. If you do plus 1 and divided by 2, you get 2n plus 2 by 2, which is n plus 1, and then subtract 1. Then then your Pascal quotients will stop at exactly midway. For much more better understanding, what I can say is, so you can see any particular Pascal row. Suppose I'm drawing the Pascal triangle 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. So you can just draw a line midway and you can see clearly in any odd row, there'll be the same elements present either sides. Okay, in any odd row, this is third row. Okay, and this is first row kind of. So there'll be the same elements present either side, and the sum of them will be exactly equal to half of the total row. So for doing that, here we miss one particular value, that is 2n plus 1 C0 is missing. So I wish to insert it and also remove it. 2n plus 1 C0, I'm inserting it. I'm also removing it. So then the value of this part is going to be nothing but half of 2 raised to the power of the row number. What is the row number? 2n plus 1 is the row number. Minus 2n plus 1 C0 will be just 1, and the value of this is 63. So it becomes 64. Half of 2 power 2n plus 1 is 64. So 2 power 2n plus 1 is equal to 128. We all know 128 is 2 power 7. So 2 power 2n plus 1 is equal to 2 power 7. So from this, we can get our value of n. So value of n is going to become equal to 3. Clear, people? So this is yet again a property of a Pascal triangle. So hope you like this miscellaneous. We meet in the next class. Thank you.